Greetings. This video is meant as a distance education learning for somebody who is taking grade 11 college mathematics, particularly for those of you who are studying the unit on exponent laws. For many of you, this is simply a review, as you've already learned exponent laws, but it will pertain to later on in the chapter as we proceed. So, just a reminder, an exponent is always comprised of two parts, the base and the power. Now, often, for those of you guys who remember, if you're using a calculator, when you're trying to look for an exponent, you have to use the exponent button, which may look like one of these three cases. So if you are going to do 3 to the power of 7, it would be 3, one of those buttons, and then 7. However, the whole point of the exponent laws is rather than take the big number you get when you're expanding, is to work with that small, finer number. So let's look at the exponent laws. Again, much of this is a review of what you've already seen. The first rule is called the product law. And for exponents, it basically works with the following parameter. Whenever you are multiplying two exponents, but they have the same base, then rather than taking the first exponent, expanding it, expanding the second one, and getting an even bigger number, it's much easier to simply look at the powers themselves and add them. Your teachers may have previously shown you this as multiplication becomes addition. So in our first example, we have 2 to the power of 3 times 2 to the power of 4. And rather than expand each number and then multiply, simply keep the base 2 and just add the two powers, so it becomes 2 to the power of 7. So one more time, multiplication becomes addition. The second exponent law is called the quotient law. And again, same starting principle, same base. But this time, rather than divide the numbers, simply subtract the powers. So your teachers may have shown you this as division becomes subtraction. In the first case, we have 7 to the 5 divided by 7 to the 2. So it's simply 5 take away 2, which is 7 to the 3. Now previously you might have learned this as expanded form, which is writing out all 5 of the 7s in multiply, all of the 2's 7s on the bottom, and then simply canceling out. But in the end, it works out the same. But again, rather than expand this, it's much easier to leave it in the simplified form. Rule number 3 is often referred to as the power of a power law. And in this rule, you have an exponent already, and it's being raised to a power. So rather than deal with multiple expansions, it's simpler just to take the two powers and multiply. So in the case of 9 squared all to the power of 3, it's much faster just to remember that powers become multiplication. So that's 9 to the 2 times 3, or 9 to the 6. And this is much simpler than the expanded form, where you have each 9 squared, and in this case it's all multiplication, so the multiplication becomes addition, and you have 2 plus 2 plus 2. So the whole point of this property is to make it faster for you to expand it. The last rule we're going to talk about today is called the power of a product law. But for many teachers, they just refer to it as the distributive property with exponents. Because essentially, it's the same rule we just saw. It's to a power, which means multiplication, but we have multiple parts within our bracket that we must distribute this power to. So that n has to go to the a, but it also has to go to the b, and in both cases it becomes multiplication. So in our first example, we have the square, which must be distributed to both the 4 and to the a. Now, just as a reminder, there is a hidden number there. That's not just 4, that's 4 to the 1. So that 2 has to get distributed to both the 4 and the a, and in both cases, the power becomes multiplication. So it's 1 times 2 and 3 times 2, or 4 squared, a 6. And despite the fact that there are more exponent laws, we'll be taking up those in another section. For now, I just want to explain the basic, and that is the exponent laws are going to become more important as we move through this chapter. And one of the reasons is to take larger numbers and to write them in a simplified form. So I have a simple example of where we might see this. Earthquake intensities, otherwise known as the Richter scale, is a base 10 system. So rather than write out numbers between 1 to 10 million, it's much easier to just write everything as a base 10 symbol. And rather than deal with the jumbo numbers, we're going to deal with smaller numbers that are easier to work with. For example, when they compare something on the Richter scale, they look for intensity. How much more intense is an earthquake with magnitude 6 than one with magnitude 2? Since the comparison refers to division, it's just 10 to the 6 divided by 10 to the 2. And again, since we know division becomes subtraction, everybody can work that out. Now, for students in my class, you've probably already received this package and therefore can go through these notes yourselves and with these basic explanations. For those of you with any questions or concerns, please feel free to contact me as you have the links. Thank you and have a great day.